Okay, so this is more like something that you will see in your homework, this type of problem. So again, this is number 2 and IS number 15 in the Check Your Understanding. So it says, biologists studying the healing of skin wounds measured the rate at which new cells closed a cut made in the skin of an anesthetized newt. Interesting, okay. So here are the data from a random sample of 18 newts. I'm already thinking it's random, that's good. And I'm thinking N is 18, measured in micrometers, which are millionths of a meter per hour. Whatever. I'll need those units later, but probably not right now. So here are my values. I need to calculate and interpret a 95% confidence interval for the mean healing rate mu. Okay, so my first step is to state, and I'm going to try to use all my space on my paper here. So I need to start out by stating the parameter and the confidence level. So I'm going to say we want to estimate, and then I'm going to state my parameter, which is mu equal to, where did it go? Here it is. Confidence interval for the mean healing rate mu. Okay, so mu equal to the true mean healing rate. Now, the problem up here gets a little bit more complicated about what that exactly is, but the statement of the problem down here makes it really clear what I can phrase as my parameter. So mu is the true mean healing rate. And I want to state my confidence level, it's said to do a 95% confidence level. So at a 95% level, 95% confidence. All right, one sentence to state my intentions here. And so the next step is to plan. And if you look at that 4-step process, it says that we want to name the procedure and then check the conditions. So I'm going to use a 1 sample T interval for mu. That is the name of my procedure. I can get that up here from the 4-step process changes for mu's. And then I'm going to check my conditions. So remember, the first condition is that we have a random sample. And it does say up here, a random sample of 18 newts. So that condition is met. The second condition is the 10% condition. So we have N is equal to 18. We want to make sure that is less than 1/10 of all newts, which I think there are more than 10 times 18 or 180 newts, so that is met as well. And then my third condition is about whether or not this fits our normal situation or our normal condition. Okay, so I have all of these values. I can go ahead and enter those into Statlet and make myself a histogram or a dot plot. So instead of spending time showing you how to do that again, I'm going to trust that you can remember how to put that into Statlet using one categorical variable and make yourself a histogram or a dot plot. Here is what that said histogram would look like. Okay, so it starts at 11. The next 2 boundaries up is 22.6. 2 more bars after that is 34.2, and 2 more bars after that is 45.8. Again, I'm not just making this up. I put this into Statlet. And this is what I got. Yours could come out a little bit differently. As long as you have a histogram or a dot plot, that's fine. So here are my first 2 bar heights, my third one, 4th one, 5th, and 6th. Okay, again, copying that from Statlet, I'm sorry. I'm now just putting the frequency over here. I don't really care how high these bars are. I'm just gonna look at the shape. So it looks approximately normal to me, right? It's a pretty loose condition. I don't see any strong skew. There are no outliers. So that's all I have to say. The sample distribution shows no strong skew or outliers. Okay, good to go. The normal condition has been met. All right, so now I am ready for that third step of do, and this is where it gives me some guidance in the previous page. It says to write out the general formula first. So I'm going to do that. I have point estimate plus or minus the margin of error. Okay, so I plug in what my point estimate actually is. It's x bar plus or minus, and then the margin of error formula for means is that t star for the critical value times s divided by the square root of n. Okay, I'm ready to start plugging in numbers. That's kind of the third step of part 3 of the do part. I know x bar. Actually, if I plug all of this information into Staplet, I need to show what I got from that as well. It told me that the mean was 25.667. The standard deviation is 8.324, and n is equal to 18. Okay, so I know x bar, I know s, I know n, I just need to know t star. So I'm gonna kind of write that out to the side here. I could use table A3 again, right? My degrees of freedom would be 17, 18 minus 1. And then my tail area for 95%, let's see, where did I get? For 95% would be that 0.05. So I could follow that 0.05 down to 17 and see that I get 2.110. That is one option. I'm going to go ahead and write out the other option using the inverse t function. So again, I have 95%, my area in 2 tails is 0.05. So if I divide that by 2, the area in 1 tail is 0.025. So if I add my 0.025 to my 0.95, and then put in my degrees of freedom of 17. Okay, so we've done something similar to this with a 95% confidence interval, which had different degrees of freedom. Yeah, that's exactly right. 0.95 plus 0.05 divided by 2. I wrote it a little bit differently. I just wrote 0.025. That's fine. Oh, sorry about that, guys. Got stuck on the wrong thing. I cleared out my area. So it should be 0.975. 0.025 plus 0.95 is 0.975. And degrees of freedom is 18 minus 1, so 17. All right, and look at that. If I round to 3 decimal places, the 8 is going to round the 9 up to 10, so it'll be 2.110, which is exactly what the table just told me. So really either way is fine, whatever you prefer. Just write whether you're using the inverse t function or table A3. Okay, so now I'm ready to plug in. I have x bar, again from Staplet, I wrote this down, 25.667 plus or minus t star, which is 2, I should probably write that this is t star out here. So that's 2.110 times s, which is 8.324 divided by the square root of n, which is 18. Okay, so I'm ready to calculate that out and get my interval limits. I can type that all into one command. So I'm going to do my 25.667 minus first, because I want the lower limit first, 2.110 times 8.324 divided by second square root of 18. Okay, so I got 21.527 as my lower confidence interval limit. I repeat that command, except I change my minus sign back here to a plus sign. Okay, so now I get 29.807 if I round up. 29.807. All right, there's my confidence interval. But if you stop at this point, you are definitely not getting full points. You have to interpret it, right? I don't care if you can come up with those numbers if you cannot tell me what they mean. So we have to interpret, which is the conclude step. Okay, so in our conclude step, we state that sentence for the interpretation of confidence intervals. We are, let's see, our confidence level was 95, so 95% confident that the interval from 21.5 to 7, and I'm going to use units here, but I'm just going to use them once because they're kind of long. So 21.527 to 29.807. And then looking back up at the problem, it was micrometers per hour. So we're 95% confident that the interval from this to this micrometers per hour captures, and then I fill in the parameter, the true mean, let's see, what was it? The true mean healing rate. Okay, I'm done with my confidence interval. So please remember that 4-step process. I will expect you to show that in your homework. Now, the good news is I only gave one problem where you actually have to work out the sampling distribution for yourself. All the others either fall into the first two ways to satisfy the condition. Either the population distribution is approximately normal or the sample size is larger than 30. So it's just one where you actually have to plug in values to Stablet or your calculator and get a histogram or dot plot and actually calculate the sample statistics for yourself. But I'm not probably going to do that to you on a test, right? If I give this to you on a test, it'll be more like this previous problem back here where I go ahead and give you the histogram so you don't have to sketch that out yourself. Okay, so I think that is about it for this lesson.